That means combining with the oxygen. C plus O2, you will get CO2 plus the heat and light. Then we have methane plus the oxygen. How much we get? CO2 plus H2O plus heat and light. Then after that, what you have? Ethanol, right? Ethanol plus oxygen. What you will get? Ethanol plus oxygen? Carbon dioxide plus water plus heat and light. Next. Which one you are writing next? Oxidation. Write down. Oxidation means what? Karthik, what do you mean by oxidation reaction? What are you doing there? One oxygen will be added there. Then what happens? What? First equation, light. Light, okay. Okay. Oxidation reaction, tell me what is that? Ethanol plus? Potassium dichromate or alkaline potassium permanganate. In the presence of that, or it is an oxidizing agent. We get what you will get ethanol? What is that? Ethanoic acid. Ethanol to ethanoic acid. Write down first. Then after that, write substitution reaction. Fast. All these are equations very important. They will give. Oxidation reaction fast. Ethanol CH3 CH2OH or this way. Anyway, it's the same thing. In the presence of alkaline KMNO4 or acidified potassium dichromate. What is that? K2Cr2O7. What you will get? Acetic acid. CH3COOH. That is acetic acid or ethanoic acid. That one. It is like this. Okay, ethanoic acid. What is this acidified potassium dichromate or alkaline potassium permanganate? What is this? This is an oxidizing agent. Okay. Oxidizing agent means what? Snetra, what is oxidizing agent? What do you mean by oxidizing agent? Okay, what is that meaning? What it will do? Oxidizing agent. On addition reaction who have not written. Substitution means one will be substituted by the other. That's it. That is, the hydrogen is substituted by the chlorine. Okay.
Hey, show the compound.
Then substitution reaction. Fast, right? Substitution reaction. Substitution reaction. Substitution reaction. Substitution reaction means hydrogen is replaced by a chlorine. One will be substituted by the other. It is a substitution reaction. Write down that. Substitution reaction. What we have? Methane plus chlorine. gas, you will get in the presence of sunlight itself, there can be the substitution reaction. Okay. So you will get CH3Cl plus HCl, you will get. Okay. Then this CH3Cl, again CH3Cl again combines with the chlorine. You will get
Hey, what made up of
CHCl3. So every hydrogen atom can be replaced by chlorine atom. Okay, so all the hydrogen atoms can be replaced by the chlorine atom. Write down all these fast. Substitution reaction. Again, this again further exposed to chlorine, again it can happen like this. So it can replace all the 4 hydrogen by all the chlorine. Huh. The names, I in the textbook. Okay. But it can happen. That is there. Write down. No, they will ask. They will ask from this also. That's why I'm telling you, right? Fast. Next, ethanol we studied, right? Ethanol combining with the sodium we studied. Right, that also fast. Chemical properties of ethanol. Ethanol reacts with the sodium. What happens? Write down. I'll come and check fast. Next, write about ethanol reacts with sodium. Huh. How much you people are talking now? Write down this. Ethanol reacts with sodium. What you will get? What is the name it called? Sodium ethoxide. Sodium ethoxide. That is one hydrogen in that is replaced by sodium. First, write down that ethanol reaction with sodium. What you will get? Ethanol is CH3CH2OH plus the sodium. You will get CH3CH2ONA plus the what else is remaining? Only hydrogen, so hydrogen gas. Huh? It's fine. This is sodium ethoxide. Sodium ethoxide. Okay. Next, dehydration reaction. Dehydration reaction. That is removal of water. So ethanol CH3CH2OH in the presence of concentrated H2, keep your head properly, H2SO4. What you will get? 2 hydrogen, water H2O. This much is removed. So what else is remaining? 2 carbon, 4 hydrogen. So C2H4. C2H4 plus the water. And this happens at 170 degrees centigrade. Okay. Next, ethanoic acid. What is the formula for ethanoic acid? Ethanoic acid. What is the formula? CH3COOH. That is this is ethanoic acid. Now, how it reacts with sodium? What happens? Reaction with sodium. 1 hydrogen is replaced by sodium. So, what you will get? That's all. So, what else is remaining here? Hydrogen gas. So, H2. This is about that. Then reaction with the base. What will be the reaction with the base? Base NaOH. Here it is there. No, double. It's, two bonds are already there. Yeah, double bond I've written. It's there, no? Double bond is there. Reaction with the base. What you will get? CH3COOH plus NaOH. What you will get? Sodium acetate only. This is plus the water now. Why water? We have OH group here, 1H. Combines, it will become water. So remaining O, 1H is replaced by Na. So this is sodium acetate. Okay. Then after this, esterification reaction. We'll study about esterification. Everything we did actually, all these. Just once I want to revise because these are very important. All these questions related to these equations, they will ask in the exam. Esterification. Okay, listen here. Esterification reaction. Listen. Esterification reaction. That means ethanol when it reacts with ethanoic acid. Ethanol when it reacts with ethanoic acid, you will get an ester. Okay. So this we call it as esterification reaction. And ester, it is used in perfumes because of its smell, sweet smell. It is used in perfumes and many places we use that compound. Okay. Right. Ethanol is what? Ethanol plus ethanoic acid. If you want, write ethanoic acid first. I'll tell why. Plus alcohol C2H5OH. In the presence of concentrated H2SO4. So what you will get? This is also actually dehydration only. One water is removed here. See what happens? CH3COOH is one hydrogen is replaced by C2H5 from this. Here it is replaced by C2H5. This hydrogen plus OH will become water. That's all. See, what is, 1 minute, what is the formula for this? Ethanoic acid. This is the ethanoic acid, right? This hydrogen will be removed and we will put C2H5. When ethanol reacts with ethanoic acid in the presence of concentrated H2SO4, we'll get the compound called ester, which is in sweet smell will be there. So it is used in the perfumes. It is also a dehydration reaction because water is removed. One hydrogen from here, OH from here, it will become water. Dehydration. Okay. Ethanol, when it reacts with ethanoic acid, you will get an ester. Sweet smell. It's sweet smell in nature. Because of that, it is used in perfumes. Okay. Right, doctor. Next, saponification. Next reaction, saponification. Saponification. Basic means?
That's basic in nature.
Why it will be basic in nature? Because ethanoic acid you are using, it's an acid. It is a salt actually. Write down. Write down this. Saponification. Write down this saponification. This is sodium acetate. Yeah, you will get sodium acetate. Correct. This one we call it as saponification reaction. What is the reason? It is used in soaps. This reaction, that is sodium acetate. It is used in the soaps. Okay, sodium acetate, what we get, that is used in the soaps. So this is also called as saponification. Okay, we'll study next. It will come. Soaps, how it is formed, all this. It's there, soaps and detergents. We'll study that portion. Okay, what is this? CH3COO C2H5. Wait. Tell Aditya, see that. What is this called? Be quiet, na. Ethanoic acid. Kiara, what is this? Why? Oops. What is this? So, Diksha, what is this? What is this? Ester. Ester, no. CH3COO, 1H is replaced by C2H5. So, ester, in the presence of NaOH, you will get ethyl alcohol back plus the sodium acetate. And this reaction, we call it as saponification. Again, I repeat, listen here. Ester, when it reacts with NaOH, what you will get? We'll get ethyl alcohol plus the sodium acetate. So this reaction, they call it as saponification. What is the reason? Because it is sodium acetate, they are used in the soaps. So ester, they will use as a raw material. When it combines with NaOH base, it forms ethyl alcohol plus the sodium acetate. Okay, this sodium acetate is used as a raw material in the soaps. That is the reason this reaction, they call it as saponification. And the ester reaction is also why it is important. This one means because ester, what is formed, it is used as a raw material in perfumes, soaps. Because to form the soaps, the saponification reaction is formed. How it is formed? Ester plus sodium hydroxide. There you will get. That's why it is important. Clear? Maybe 8 marks, 7 to 8 marks. In 88 marks is 10%, no? Physics, optics, that is light chapter, carbon compounds from this chemistry, all these are important. Or your life process and how do organisms reproduce, all these they will get. Maybe 3 or 4 marks. That's it. This is done. Written Lakshit? Done? Okay. Shall I clear this? Right. So understood, everyone? Saponification means an ester, when it reacts with sodium hydroxide, you will get ethyl alcohol plus sodium acetate. Okay, that is C2H5, which combines with OH, and CH3COO combines with Na. You will get that. And this sodium acetate is used as a raw material in the soaps. So ester, they combine this, actually they use in the industries. That is a reason it is called as saponification reaction. Reaction with carbonates and hydrogen carbonates. So carbonates means what? It is CO3. What about hydrogen carbonate? HCO3. So ethanoic acid, how it reacts with carbonate group and hydrogen carbonate. Write down. CH3COOH. This is ethanoic acid. When it reacts with NaHCO3, that is sodium bicarbonate or sodium hydrogen carbonate. What you will get here? Same thing, sodium acetate, COONA. Plus, what else is remaining here? Hydrogen and carbon. So, water you will get plus the carbon dioxide. Okay, then CH3COOH plus sodium carbonate, that is Na2CO3. Here also you will get sodium acetate, CH3COONA plus the water plus carbon dioxide. So here also you are getting sodium acetate. Write down this potassium salts of long carbon chain. Don't talk, write down long chain carbon. Long chain carboxylic acid. General formula. Okay. Write this, will explain.
Soaps and I'm good. Soaps.
First you write, I will listen. Soaps are what? Sodium and potassium salts of long chain carboxylic acid. Carboxylic acid is what? It can be anything. Here we studying about CH3COO, carboxylic acid with the sodium. That is sodium acetate is also a one sodium salt of long chain carboxylic acid only it will come. This is write down I'll explain. Long hydrocarbon chain. This is hydrophobic in nature. Hydrophobic. Okay, this is ionic part. Hydrophilic. And write this structure also. Write this.
What is that mean?
I will explain, right, man. That's when you first write, man. Don't talk. Write down and explain. Yeah, let it look like a resistor. You write. Formation of micelles. Okay, structure of soap molecule. A soap molecule will contain long hydrocarbon chain with the sodium or some ionic compound, right? So it is long hydrocarbon chain is hydrophobic in nature, whereas that sodium or any what you will have the metal, right? Na plus or any ionic part, that will be hydrophilic in nature. Here we will end the today's class. Do not forget to subscribe the channel. If the content of this channel is useful, please like the video and share with your friends. Thank you.